In this recording, I will be going over the installation of the tidyverse package, how do we use the tidyverse package, and specifically two packages within that set, which are a readR and tidyR. To install the tidyverse package set, one has to type in the following: install.packages in quotes tidyverse. And once you go ahead and run it, your R installation is going to go ahead and look at the CRAN repository for tidyverse. It's going to be downloading a variety of other packages that are required for tidyverse, and it's going to be installing them as part of your R and RStudio environment. Once this is successfully concluded, you have your tidyverse package set ready to go. You can find it if you click on the Packages tab and scroll down to tidyverse. You will find the tidyverse package is a set of packages to easily install and load the tidyverse. And so to use tidyverse, you type in library or require tidyverse. And once you go ahead and run that second line, you will see that all the packages associated with tidyverse are now ready for you to use. Once you've done this, you don't need to install tidyverse once again because it is already present in your system. All you need to do if you want to use tidyverse or any other functions present in the packages of the tidyverse, you need to just type in library tidyverse before you go ahead and use any of those functions. The first package that we're going to be taking a look at is the package called readR. readR is a package that allows us to read data in from a variety of different sources. If you scroll on under the packages menu and look for readR, you will see that it has in fact been loaded, and if you click on it, you will find that it has a variety of different functions that are present in here. And so we can see the parse functions, we can see the read functions, and we can see the write functions. Obviously, this is a package that allows us to read, write data, parse data in different ways. Very simply, let's start by first reading some data in. Now, we can read data in from local files that are present in our working directory in R, or we can read files in from an online source. The first thing to note is in the readR package, the read functions have a read underscore, and so we have read underscore CSV, CSV2, dlim, so on and so forth. And so I shall start by declaring a variable or data frame called central park temps, into which I'm going to read data in from the following file, from the file called centralparktemps.txt that is present in my current working directory. So I should be typing in read underscore CSV, and when you type in read underscore CSV, a menu pops up, and you can see that read underscore CSV is associated with the readR package. We also have a read.csv, and this is part of base R. And so we're not going to be using the base R read.csv, but read underscore CSV that's associated with the readR package. And so within quotes, I shall be specifying the file that I want to read. In this case, it's going to be centralparktemps.csv. And if I just type in the following and run this line, you will find that it says that the file does not exist. And the reason the file does not exist is because I have obviously made a mistake. It's .txt and not CSV. So I read into centralparktemps the data frame centralparktemps.txt. If I run this, it successfully executes. Now, a couple of things to notice that this data frame has 3 columns, and information about the columns as they are read in is specified down here. Year was read in as a double, month was read in as a double, and temperature was written as a double. If I want to take a look at this data, I can type in head of central park temps, and I see the first 6 rows. I see that I have a tibble. It's the equivalent of a table in R, and we have year, month, and temperature, um, which are of the double data type as they were read into R. I can also take a look at the dimensions of this table, head and dim being base R functions. So we see that we have 1,765 different rows and 3 columns. Um, and so this very simply allows us to read data in um, from a text file. Now, in this case, the file was present on my local computer, but it does not have to be present on my local computer. I can say Central Park Temps remote. I can also read data in from an online location. So read_CSV, and I can specify the URL that my file might be present at. So I say http:// I have a bit.ly URL. And if I read in from this remote location, again, the data comes in. Year, month, and temperature were parsed as double data types, stored in central park temps _ remote. Now, in case I want to make a choice, as in these data types are not really the data types I'm looking for, I want to specify the data types that I am interested in. One of the things that I can do is I can say that I want to read this data in with certain specified column definitions. So I can say, so I'm just going to modify central park temperatures, read CSV. I'm going to read central park temps.txt in, but I am now going to specify certain column types. And I'm going to say that I have my columns set to certain values. And my column values are going to be the following. I'm going to have year as a character column. I'm going to have month as a character column. And I'm going to have temperature, all of these coming in as character type columns. Now, if I go ahead and run this, you will see that central park temps has been read in. Central park temps.txt has been read in. And once it has been read in, you will find that central park temps now has, just to make sure you guys see it, year, month, and temperature as character data types. Now, if one wants to actually change the data types for any of these columns, one can do that by using the parse functions. The parse functions allows me to change the data type of any column I might be interested in. So for instance, I have parse double, parse factor, parse integer, and so year and month typically are integers, so I might want to say something like central park temps $year is actually going to be parse integer. So I'm taking the year value of year column of central park temps, running it through the parse integer function and storing it back in the year column. And then if I then take a look at the head of central park temps, you will see that the year column is integer, the month column is character, and the temperature column is character. This way I can read in all of my data as character data type, and then customize the data type based on what I'm interested in. So I would think that year, and not just year, but month is also likely to be integer data type. And lastly, I shall be parsing temperature as a general number. And then if I run head of Central Park temps, I find that year, month are integers and temperature is a double data type. Now, there are a variety of other options that we can implement. So as we are reading data in, we can decide if we would like to skip any rows of our data. And one can do that the following way. And one might find this sometimes in cases where you don't, you have some dirty data, messy data, some header information that's present in rows, but that you don't actually want to read in. And when that happens, you can skip rows the following way. So in Central Park temps, once again, I will be reading data in read_CSV, and I'm going to be reading in the txt file. But in this case, I am going to be skipping some rows. I'm going to specify I want to skip a certain number of rows. Let's say I want to skip the first 100 rows of data. If I do that and I run this, notice that the first thing that happens is that my number of rows goes down. Central Park temps remote, which was properly read in 1765 observations of 3 variables. Central Park temps, which I just recently read in with skip equal to 100, has read in only 1665 rows of 3 variables. And if I run head of Central Park temps, you will find that we have, in fact, a header that stands for 1877, 12, 13, 37.4. It has skipped the first 100 rows and taken the 101st row as the header row. And this is one of those things that we can actually fix, because it could be the case that you want to skip the first 100 rows and you want to also indicate that your table does not have column headers. And so one can do that the following way. So I can say call names false, indicating that I don't have column names. And now if I take a look at head of Central Park temps, you will see that it has assigned some generic headers x1, x2, x3, my data starting at 1877, 12, 37.4. Obviously, this is a hypothetical scenario because in my case, Central Park temps does in fact have an appropriate header, year, month, and temperature. One of the other things that one can do using the readCSV function is use or using the readR package is specify your delimiter, specify the manner in which your columns are separated in your text file. And so to do that, we will use the read_delim function in the readR package. Read_delim allows us to specify the delimiter that we wish to use. And so sticking with the Central Park temps example, I'm going to be using the read_delim. In this case, I'm going to be using, again, Central Park temps txt file. In this case, since I'm using read_delim, I have to specify what the delimiter is, how are the columns delimited. I know the delimiter. The delimiter is in fact a comma in my case, or in this case, because I know this is a comma delimited value file. If you actually have a different delimiter, such as a tab, if you have a semicolon, if you have a pipe operator as a delimiter, if you have a dollar symbol as a delimiter, you can specify all of those options right here. as a delimiter. And so once I do that, you can do just that. Again, I'm leaving the default specifications of columns in place. And so my central block temperature comes down as expected. One of the other things that the readR package does is it allows us to write data out. To write data out to a CSV file, we want to use the function write_CSV. When you want to write data out, you have to specify the data frame you want to write out. Let's say I want to write central park temps out, the data frame, and I want to write it to a file. And again, that file that I'm writing out is going to be stored in my current working directory. And in this case, my current working directory is our code, and I'm going to give this I'm going to call this cnytemps.csv. And if I do that, you will find a file called cnytemps.csv. If I view the file, you see it right here. One of the options that R also allows is to read data that is present in the clipboard. For instance, let's say I have this file right here. And this obviously has a description of documentation for the readR package. So one of the things I can do is I can just scroll through this entire list of packages right here. And what I'm doing is basically I'm trying to find the best way to select these columns. Let's say I come down here, and I'm just going to hit Control C. I'm just going to copy this. If I hit copy and if I hit Control V, you will see that this is whatever I've copied has been like pasted out over here, right? The readR package allows you to take data that's present on a clipboard and paste it into a data frame or save it into a data frame within R. The following through the use of the function called clipboard. And so if I have a data frame df, I can say clipboard, open close and parentheses, and I can store the data that has been present in my clipboard right here. And so if I type in df, you see the data that was present in the clipboard is present right here. And so we see that it is a character vector with around 13 to 14 rows.